So what is the difference between time and space behavior of a wave? The tricky part of understanding wave motion is recognizing the differences between the time and space behavior. Hopefully the animation at the bottom here can help. The top part of the animation shows a sine wave pulse traveling from left to right. A red dot has been identified to highlight the time behavior of a point at a specific location. Below is or are two graphs, one that studies the variation of amplitude as a function of time, and the other studies the variation of the amplitude as a function of position. What do we mean by studying the variation of the amplitude as a function of time? This is more like recording a video for the highlighted particle. So we fix the position, we keep on recording the video at this position, but time passes, but within an interval of time. However, studying the variation of the amplitude as a function of position, this is more like a snapshot. It is taking a photo of the behavior of all the particles in the medium at a certain instant. So this is the graph shown clearly here, the variation of the amplitude as a function of time. This graph represents the wave as a function of time for a specific location. Nothing happens for the first few seconds until the leading edge of the wave reaches the location of the red dot, and we can see it here clearly as a horizontal straight line. So this initial time before the pulse reached the highlighted particle, the behavior was zero. No vibration was happening. Then when the pulse reached the particle, it started vibrating up and down. Now once the wave reaches that location, the position oscillates up and down with time as the wave passes through. After the wave pulse has passed through, the displacement returns again to zero. Now, the amplitude as a function of position is more like a snapshot of a wave, for example, at t equal 27 seconds. At this instant, a picture was taken for the whole medium. How did it appear as such? So this graph represents the wave as a function of position at specific time. The graph represents a snapshot, a photograph of the wave at t equal 27 seconds. The graph is blank for the first 20 seconds. Then the graph appears all at once and does not change.